Hi guys, my name is Eila. It's my second time at the summit event and it's good to be back always. I'm going to talk to you about the way my company is using Apache Beam. Eila Research Therapeutics' goal is to make precision medicine a reality, and we use a lot of Apache Beam for that, and I'll show you the Conda part of it. So our agenda for today is going to be who is Eila Research, what do we do, example of the use of Apache Beam with Conda for RNA data processing, and we'll have a real RNA to work with, a demo, and I'll give you time to try it. I think it's gonna be 20, 30 minutes, but we'll see as we go. Okay, we are located at the Kendall Square in Cambridge, Boston, Massachusetts. We have a team of individual from leading educational and research institute. I myself work for the Broad Institute of MIT and Harvard, Mass General Hospital, the Whitehead Institute of MIT, Microsoft, and all the others have a very good reputation as well. Our mission, like I said, is to make precision medicine available for anyone, everywhere. I'm going to give some more information about the way we do it for leukemia early detection on Friday. So if you're interested, there is a quick lightning talk that you can join us. So the reason that we do our work is because we were thinking, what if we could shorten the time from disease onset to diagnostics? What if we could detect multiple diseases in the annual physical checkup of the patient? What if we could detect multiple diseases within one disease? And what if we could initiate treatment before symptoms arrive? For many diseases, it could broaden the treatment options, increase the chance of cure for certain diseases, and also reduce treatment costs and frustration for the patient and for the physician. So our early detection tests utilize RNA sequencing, big data, and machine learning-based methods for early detection tests. All the tests are continuously updated with more data as machine learning practice require. Currently, we have acute myeloid leukemia and sepsis tests that we are working on, and we are going to start working on the MDS syndrome very soon as part of our research on the leukemia. This is a disease that is a benign disease that usually drives to leukemia. Right now, we are validating our leukemia test with the Johnson & Johnson incubation that we are part of. So in this figure, you can see where from the disease onset, our vision is to have a blood test that will be sequenced, and then we can get into diagnostic instead of many hops on the way until we get to diagnostic currently. Just some background about us. We are about 2 years old. We have a client from the Mount Sinai Cancer Institute. We joined the Google Cloud for Startup community, and also the Johnson & Johnson Innovation Lab incubation. And by the end of last year, we had our first leukemia early detection test available. Our solution include the data, analysis, cloud pipelines for processing genomics and clinical data, early detection tests for leukemia and for sepsis. In both of them, we're getting very high accuracy, but we are improving that all the time. Some about our platform. We are using Airflow with Apache Beam. Here you can see Airflow graphical user interface where you hit the play. The play is initiating a Apache Beam pipeline, as you can see here, which each task this is not Apache Beam pipeline, this is the Airflow pipeline, and each task is initiating Apache Beam pipeline, where we are using a multiple steps, minimum dependency as can done with Apache Beam, maximum computing time, and minimal cost. Example of the data that we are generating from our clinical information is this table of BigQuery. We're also generating a Google Sheet straight from Apache Beam, and I think this is something that many people are using Apache Beam to create. So we're skipping the Beam query and the BigQuery and creating a Google Sheet with Apache Beam. But today we're going to talk about Apache Beam and Conda. Why do we need to use Conda? Many of the genomic processing tools were developed to run on a single powerful machine, not in parallel on multiple machines. And the tools are not following the paradigm of processing peak collection in and peak collection out. So I'll show you exactly what I mean by that in the code, but you used to, when you write a pipeline in Apache Beam, to get like a row or some kind of or text or a file, process it, and then bring back a peak collection for the next transformation or for the syncing of data. And here we're not following that paradigm. We're actually getting peak collection and then running DoFN and writing the result to the Google bucket. And for these kind of tools that are being developed sometimes in research institutes, sometimes in the industry, the cleanest way to install them is with Conda. When you try to install them by hand, like library by library, usually you have a lot of dependencies issue. So how will the pipeline look like? First step is going to be to get the list of files or any kind of peak collection that you are needing. In our case, it's going to be the list of the RNA sequencing that we are going to process. And then the next step is to have a worker that is being installed with Conda and then being installed with a library that uses Conda for its installation. And then the worker machine will process the RNA with this specific library. And since the worker machine is going to be used in the next peak collection, when it's finished this peak collection or few peak collections in parallel, you have to clean the machine, otherwise you're running out of memory. And this is something that you usually don't do when you are working with a peak collection that is data in, data out. So step for workers installed and running Conda packages. First, we're going to create a notebook machine to work with. I'll show you my data lab that I'm working with. And then in the Apache Beam setup, we're going to install Conda on the worker machine. And then we use Conda to install a software tool that we are interested at. Execute the software tool as part of your Apache Beam pipeline, and then clean the machine after copying the result that you have on the worker to your Google Cloud bucket. So you won't run out of space if you have a lot of samples that you want to process. I already shared on the chat, so check out if you can see that. And it's basically, and I can try to share again, it's basically a few folders and files that will be used as part of our workshop. So whether you all have this and can access it? Chat, I have a chat here. So just if someone can tell me on the chat that we can, that it's accessible, that will be great.
Yeah, sorry about that. I was muted. Yeah, we can see your.
Just if you can click on the last link and let me know if you can see this.
Yes,
drive.
we were able to open it. Yeah, it has proper permissions to allow others to open it.
Okay, excellent. So basically the in for our pipeline will be an RNA sequencing data. You'll have FASTQ file under this one. Just an example, you can use later any in and any Conda library that you want to use. This is the expected FASTQ-C output that we are going to see. This is the installation, the shell of the script of the Conda. Setup PI is going to be used by the Apache Beam and the code that we are going to be running. So let's start by creating a notebook machine to work with. I'm going to use the data lab. This is the command to create a data lab machine. 4 CPUs will be more than enough for you right now. So I don't know if people want to try that. I'll give you a few minutes. And sometimes when you create a data lab, it fires an error on you. I copy this error. I don't know why. the best way is to just quit this process. It was already created and then connect to the same machine. This is the name of the machine. You can use a much shorter name, so it will be faster for you. So I'll give you a minute for that, Pedro. Will that work?
Yeah, that's fine.
So that's going to be your output. Once you complete it, that's going to be your output. At the code itself, let me make it bigger for you. You have this one available here. And if you get an error, yeah, I see people in the file, so you're fine. You can just copy that and that will be faster.
Oh, Mahesh is asking us where they need to run the command. I guess you would do it from the, yeah, please go.
From the shell. Yeah, from the shell, from the Google Cloud shell. Or if you have a G-Cloud installed on your machine, you can do it from the terminal. I can show you here. So this is one place. If you have G-Cloud available, I'm just now connected to my Data Lab Apache Summit that I created from my terminal because I have the G-Cloud already installed. So basically I can create another machine. Data Lab create, try. If you don't specify the number of CPUs or anything else, it's gonna ask you for questions and you can decide as you go. Right now it's asking me for region. I think 8 is central, so I'm using central, hitting yes. And that's it, it's generating the machine. Sometimes after I generate the machine, it fires an error. In my case, it's not gonna be able to connect because I'm connected on this port already. It's using the port 8081 and I already connected to my machine, to the Apache Beam machine, this one that is here. You're gonna see the machine also in your VM instances view. So that means the machine was created. And now if I hit this, I should be able to connect. But since this port is already used by my other machine, it's not gonna connect. I'm gonna get an error. But you guys shouldn't have this issue. If you have any issue, just Control-C and try to connect instead of create. Can anyone tell me if it worked out for him on the chat?
Probably, I guess we have some attendees who are still installing the data lab and connecting it to a
Okay.
G-Cloud account.
Okay, so Pedro, you tell me when do you think it's the right time to move on? Because I don't.
Yes, I guess let's move on. Our participants have the material and they'll have the recording in case they or unless somebody tells us in the chat, hey, wait, I need a minute. Otherwise, we'll carry on.
Okay.
Yeah, let's carry on.
I'm carrying on.
Yeah.
And if you guys want me to stop at any time, just let me know. So that's the data lab machine that you're gonna get. And then the first thing you wanna do is they install Apache Beam so we'll be able to use it. So this is also code that you have available on the document. Just copy it as is and run it. I can show you my machine. Okay. basically what I'm doing, I'm hitting the shift return or hit the run here and copy the code here. What you're gonna see is something like that. Once you complete the installation, that's gonna take, I think, a minute, maybe less, maybe a little bit more, depends on your machine. Then if you took a machine that is very small, one CPU, then it's gonna take very long. If you're taking a machine like 2 or 4 CPUs, like I was recommending, then it's gonna run faster for you. And then you can hit the reset session here after the installation. So once we have the machine, now we're working on the part of the Apache Beam and the Conda. So we'll start with installing Conda on the worker machine, or at least letting the machine know that we want them to have the Conda installed on them, and then use the Conda to install the software tool. In our case, it's going to be FastQC. In your case, it could be any other tool that Conda is offering. The file that is going to be very instrumental in this case is the setup Python file that you can point from your pipeline setup. So you have, if you want an example of this file, you have on my drive, and this is following the example of the Julia set setup file by Apache Beam. So this is the file that you have on the drive, the setup py. The commands that I'm using here, and I'll explain you command one by one. What does it mean? It's basically Unix-based command. Here we're using the gsutil to copy from the Google storage. So you'll have the Anaconda shell script here at the drive, and you'll need to copy it to one of your Google buckets and while the worker is starting, you're asking to copy it from your Google bucket to the machine itself. This is a drive that is available on the Apache Beam worker machines, and it's user owned, and that's where you usually copy things that are that the user brings from outside. The next one will be change mode the Anaconda shell script to an executable, so you'll have permission to execute it. The next step will be to run the installation of the Anaconda, and that's what we are doing here. And the next step after that will be to use the Conda that was already installed and the user on Conda being Conda installed the new library that you want to work with. This is the FastQC, and this is the command that Conda is publishing for this library. So basically, we copy the command and separate each one of the parts of it with comma and string quotes. And the last step will be to change mode to the Conda shell, which is basically one of the scripts that is responsible for the profile. So we will be able to use it from within the worker itself. So every user can be, the user that is actually running the worker will be able to run that. Another package that I personally use a lot is the TensorFlow. There is a place to put pip install based packages, and TensorFlow allows many utils tools that can be used when you want to copy things from your worker to the Google storage. So that was how to install the Conda on the worker machine and how to use Conda to install the software tools. And now we want to be able to execute the software tool as part of your Apache Beam pipeline and clean the machine. So this is going to be the pipeline itself. The first step will be to create the pip collection from the RNA-seq. So in your drives, you'll have the RNA-seq in one of the folders over there. I'll show you here. So let's click on the link. It's taking long. I'll show you in a second. Okay, so this is the file that we're actually putting inside. You'll have to copy to the bucket to be able to run this specific pipeline. So you'll have to copy to your bucket. This is going to be the output that you're going to get and copy back from the worker. So this is the input. Very slow, the connection. So I'll move on. I'll show you in a minute. And then here we use the PowerDo, the doFN, to process the FASTQ file with the Conda library into FASTQ-C file. The code itself in the pipeline is going to look something like that when we are pointing to the setup Python file, and you'll have to change to make sure the setup Python file is the same location where you run the code for your pipeline, and that you have your bucket URL set before you're running that, and of course the region that is appropriate for you to reduce your cost, though this one specifically is going to be super cheap for you. The code itself of the FASTQ to FASTQ-C, oh, it's very small, I think. Make it bigger. So here we take the file that is on the opt user owned folder, and we are copying the file from, this is the folder that we are going to copy our file from our Google bucket into the local folder with the name RNA-seq as you saw on the drive. And then we are going to run the Conda. So this is actually the Conda execution. We're using the subprocess command to initiate the environment of the Conda, and then run the command and deactivate the Conda environment after we are done. So this is, if you remember the last shell script that we allow execution with the change mode on our setup Python. And then we are running the Conda init, and then the Conda activate to activate all environment. Basically, we have only one environment. We're running the FASTQ-C command with our local folder, references. Again, the reason we are doing that is that we cannot use this command with Google Cloud storage, and we want to be able to do multiple parallel processing with tools that are not being and process many fast, in our case, FASTQ files at the same time. And here, the last command of the Conda deactivate. This is the way we are running it on a shell script, where the working directory is on the worker machine where we installed the Conda library. And once we're done preparing the command, we are running. This is the way to run the process. Once we are done running the process, we are taking the local folder FASTQ file. This is local folder on the worker machine that we are copying into the Google storage file, and making sure we are deleting whatever we have on the worker machine, because the way Conda Apache Beam is working is reusing the machine for more than once to be able to make the parallel processing. Many times in the cases of Conda usage, and when you work on your actual machine, and sometimes it's heavy processing, in our case, in bioinformatics at least, I'm using I don't know what happened here, but I'm using the worker, a number of workers, or the size of the worker, or the CPU of the worker, with the options of the pipeline to make sure I have enough compute power and disk to make the computation. So that's it on how to use Conda on Apache Beam. And if you want to try it yourself and ask me questions, I'm here. And the code is available. I'm gonna check in a minute why my connection has stopped, probably because I started the other machine. So I'm gonna make the notebook available for you in a second. And that's it. So Pedro, to you.
Okay, that was fast. We have, I mean,
yeah, I was hoping to see some problems, but
well,
yeah.
I suppose, I mean, in my case, I was following up, and yeah, it's taking more time. In my case, I had to first enable the APIs that I hadn't enabled yet. I was starting like from scratch.
For the data lab.
Exactly,
Yeah.
the data source repositories, and but so yeah, that took a bit, and I'm going through the first steps. Yeah, it took a while for me. I don't know if it was similar for other participants. So yeah, like Ayub says that he didn't have a GCP account, so he's going through that. I see that, I mean, everybody has the document open with a code. We have everybody checking that out.
They don't use GCP. Yeah, I was yeah. I can use Apache Beam with the Amazon Web Services or something like that. But it should work the same, isn't it, Mahesh?
Yes, yes, it should.
Because the changes in the pipeline and the setup Python. So instead of copying to GS, no, it's not a GitHub. I share the link to the code. So this is
I'll paste it again. Don't worry. Let me put it again.
Okay. No, I didn't. So whoever not using Google Storage, you can copy to your S3 or whatever you're using. The part of the Apache Beam being installed in Conda, this is the trick here, to be able to use the setup in a way that will allow you to run something with Apache Beam. So basically, whatever, I don't know, the way you are making the options, I don't know if the options itself are different in the case of Amazon Web Services, but whatever is parallel for that should be done just the same. And the thing is how to use the setup Python. And many times Apache Beam is not being used in such manner. In this case here, the output that you're going to see is going to be. So Peter, were you able to have a working machine?
Yes, yes, I got it now.
Okay. It's a Merfilo, no? Machine is not responding to me. Basically, here you can see an HTML file that is presenting the quality of the RNA sequencing in this specific RNA sequencing file. So that's the kind of output that you will see from that code. That's the kind of output that our code will bring. I don't know if it's interested to anyone. Basically, you see here reads from the RNA and the quality of the reads that coming from the RNA. This specific tool is something that impossible to work with the GS or with any cloud type computing, and the only way for us to work is to be able to install the Conda on our workers.
We have a question from Michael. Is there a benefit to doing Conda install inside a do-fn instead of inside setup PI?
I think the reason to do it with setup Python is that you'll get all the worker machine that's being spinning out with the Conda. Otherwise, you will have on each execution installation of the Conda, and you're using the machine more than once, for more than one P collection. So you have a lot of redundancy installation. And I must say, it's not an easy task when you're not the owner of the machine. And you don't know the owner of the machine when you are spinning the machine on the do-fn, to be able to allow yourself the execution permission that you were able to do on the setup Python. So you might have a permission issue, but let's say you solve this issue, there's a lot of redundancy of installation. The reason we had to clean the machine is because the machine was used more than once for processing, and then we were running out of space. So if you use the do-fn in each do-fn installation, then you'll make more than one installation of the same thing on the machine on each execution. And then probably the installation of the Apache Beam. So I'm using either the version 22 or 23, 0.22 or 0.23. The reason I'm making this kind of installations is because the data lab itself is not coming with the relevant installation for me. So I'm doing that. And also there is some workaround here. I'm going back to PIP 9, and I think we're already in PIP 221 or something like that, or 18, 19, 20, something around that number. You might, on your own environment, it might be different installation, and maybe it's already coming updated. Data Lab is a great tool, but not always up to date with the latest installations. So that's why I'm using that before I'm spinning the Apache Beam pipeline. But for you, if you're already with Apache Beam 23 or 22, you're all good to go. You don't need to do this kind of installation. It's just to bring me up to the latest version of the Apache Beam.
Okay.
And the reason I choose the Data Lab is that because I'm using the Google platform, and this is like a main hub where I can use all the other tools from the Google Cloud, the Airflow that I'm using, or BigQuery, or in our case, even Google Sheets, or the bucket, of course. But basically, it's the one place that I can operate all the tools that are providing. So that's the reason the choice in Data Lab. But any other notebook or editor or Visual Studio Code or whatever you are using can work as well.